All right, everybody should have a protractor, but before we start constructing these triangles, there's a couple problems I just want to go over with you to make sure we have a clear understanding. Now, you remember with the last learning target where we took an expression, 3x plus 5, added that to 2x minus 6, and set it equal to 180 because the angles were adjacent and formed a straight line? You guys remember doing that on your test? They were supplementary? Yes or no? Yes, okay. Well, we're going to be doing that again. Except it's going to be in a triangle. Let's make this 3x plus 2. So we have 2x, we have x plus 4, and we have 3x plus 2. Have what? Yes. The one triangle that usually will never be equilateral is a right triangle. Okay, the one that has, the verticals, the height, and the one that has the base. Okay, that one usually is never equilateral. So, how do we set this up? Just like we set up those problems with intersecting lines and supplementary and complementary angles. We take angle 1 plus angle 2 plus angle 3 and set it equal to 180 degrees. Right? Remember doing this now. And then we use that phrase called combine like terms. And remember to always circle the sign in front of the variable or circle the sign in front of the number. That'll tell you if it's positive or negative. So how many x's do we have here? How many x's do we have here? How many x's do we have here? So what's 2, 1, and 3? Okay. Are the signs the same with the 4 and the 2? Okay, so then because the signs are the same, we add them. What's 4 plus 2? Equals 180. And now what do we do from here? Christian. Inverse.
180 minus 6.
Very good. And then, because this is a multiplication problem, the inverse of that is division. So we divide by 6, and we get x equals 29. So nothing new. That's not new. You did that last test. The only difference was sometimes this was 90 degrees. Sometimes this was 174 degrees. Sometimes this was 39 degrees. Sometimes this was 112 degrees. We're talking about triangles. So what will this number always be? It'll always be 180. Always. It'll always be 180. You don't have to worry about any other number being placed there. We're talking about a triangle. All three angles add up to 180. Doesn't matter what type of triangle you're talking about. Whether it's equiangular, acute, obtuse, right, equilateral, isosceles, or scalene. Has no bearing on what number goes here. It's always 180. Okay? Any questions? Any questions about combining like terms? All right. What kind of a triangle is that? According to angles. According to angles, Emma. It's a right triangle. Now it's time to name the side lengths. What is the name of each side? I'm not asking you how long each side is. I'm saying what's the name of each side? Anybody know what we call the bottom of a triangle? Actually, the name of it's in a song. Hannah?
Is it the base?
It's all about that base. Yes. It's called the base. Anybody know what we call this vertical side? Probably. Oh, it is. Very good. If anybody know what we call the diagonal side? Anybody gets this, you get 100 pirate bucks. James. The slide. Yeah, no. I know it does. Nick? No, it's definitely not width. Let's see if you guys can even pronounce this.
Hypotenuse.
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 Not hypothesis. It's called the hypotenuse. I have no idea really where that word comes from. I just know the side opposite the 90-degree angle is called the hypotenuse. Okay? So we have the vertical side is called the height, the bottom is called the base, and the side opposite the 90 degrees is called the hypotenuse. Now watch this. Okay, what do we call the bottom?
Base.
And do you know what we call these diagonal sides? Hypotenuse? No. Height? No, height is a vertical. Think about when you go to the doctor. Do you stand like sideways when they measure your height?
No.
No, don't you stand up straight and tall, maybe even sometimes on your tippy toes? You have two of them. Legs. This is called a leg. And that's called a leg. Those are called legs. The only time you will see a hypotenuse, remember what I said, the hypotenuse is opposite the 90 degrees. Is there a 90-degree angle in this triangle? No. There's no 90-degree angle in this triangle, therefore there is no hypotenuse. It's just legs. Just legs. Any questions? So we're going to be using our protractors to construct these triangles. We're actually going to be making triangles, Nick. And the first triangle we're going to draw, or attempt to draw, is one with a 20-degree angle, a 60-degree angle, and a 100-degree angle. Can this be done, yes or no? How do you know? Because it equals 180. So smart. So anytime you are constructing a triangle, the very first thing you have to draw is the base. We always start with the bottom. We start from the bottom, and now we're here. So let's. I'm going to leave some room because I have no idea how small or large this is going to be. So I'm just going to draw a base. And then I'm going to put dots, end points, I should say, end points at the end of each segment. What letters do you want to use? All right, A, B. Now we need to make the C. Now before we move on, okay, everybody's got their protractor, right? Everybody sees this hole, right? Everybody sees these black lines, right? The hole goes on the The hole goes on the vertex. These black lines go on the segment. It's not a ray. We're not making angles. So let's put it on there. Put it on the segment. Bam. So, where's the 20-degree mark at? You guys see the 20-degree mark? Where's it at?
It's right there.
Come up to the board and show me. Which one do I use?
Use this one right here.
Okay. That is correct. So we'll put a dot there.
You put a dot there too?
Yeah, go right ahead. Put a big dot there. Now, when we connect these, how many degrees is this angle? 20. We just constructed that. That's 20 degrees. So we can put 20 degrees in there. And if you want to go back and make sure it's 20 degrees, go ahead. Use your protractor. Bam, right there. How many degrees is that? 20. Now, what's our other angle have to be? 60. So we are now going to take our protractor from point B, and now we're going to apply our protractor to point A. Does everybody see where 60 degrees is? Okay, make a little dot up here by 60 degrees. And then connect the dots. And then how many degrees was this angle right here? 60. And then this big dot right here, it's going to be letter C. And how many degrees would that be? That's going to be 100. Now, I should have been using pencil so that I could go through and erase all that nonsense. That's why we use pencil. And of course, I'm not using pencil. So we just constructed our first triangle. You see it? Well, how can you not see it? All right, let's try another one. Let's see here. Let's go. $50. 65. Oh, what would the third one be? Emma?
It'd be 65.
It would be another 65 degrees. So, what are we going to draw first? The base. And I'm going to use pencil this time so that I can erase when I'm all done. There's A. There's B. So what angle do you want to construct first? Yeah, go ahead.
I know we're doing triangles, but wouldn't that just be 180 by itself? If it didn't have just, if it just had a drop in the middle?
What do you mean?
As an angle, wouldn't it be like
This?
80?
Yeah, that's 180 degrees. It's a straight line. That's 180. All right. So you guys said you want to start with 50 first?
Yeah.
All right. So let's put, you know what? Let's switch it up. Let's start with letter A. Let's start with letter A. So let's put our hole on letter A and then mark our 50 degrees. It's way up there. So I got my 50 degrees marked. Connect the dots. Everybody got that? And from here, let's move over to letter B. Put our protractor on letter B. And then what do we need to mark?
65.
65. And 65 is between?
70.
Correct. And so let's connect the dots. And let's see what happens. Uh-oh. Uh-oh. What happened? Look at that. Is that a triangle? No. So what am I going to do? Right. Just extend this. Just extend it a little bit further. And there you go. There's letter C. And then this is also 65 degrees. Angle A is 50 degrees. Right? You see that? Okay. Angle B is how many degrees? 65. And angle C is how many degrees? 65. So we have a 65, 65, and 50. Now I'm going to take this one step further. Classify this triangle. Classify it. What kind of a triangle did we just create? Kate? We don't know if it's equilateral or not. Adriana? We don't know yet. Nick? Christian? It's definitely acute. And now let's see if it's equilateral, isosceles, or scalene. Use your ruler. All right, the base is about 3 3/4. One of the legs, this leg is 3. And this leg is 3 3/4. So we have 3 3/4 of an inch, 3 3/4 of an inch, and then we have 3 inches. So what kind of a triangle is this? Equilateral, isosceles, or scalene, Alex? Isosceles is correct. Let's bump back up to number 1. What would you guys classify that triangle as? Acute, obtuse, or right? Nicole? It's definitely obtuse because of the 180 degrees. And now let's measure this. AB is 3.5. BC is 3. And AC is 1 1/4. So we have 3.5 inches, 3 inches, and 1 1/4 inches. So what will we classify that as, James? 1 1/4, 3, and 3.5. Equilateral, isosceles, or scalene? Not sure. Zach? Scalene. Because none of them are the same. James?
I have a question about the bottom.
Yeah.
Because the string goes, does that mean it's on a slant moving the other side? I noticed it was at a slant, like going up, different than the other one.
What do you mean? I don't...
I mean that this is, has a longer way up than the other. This is just going direct between the
AC?
Yes, that's...
Okay. Now think about this. It's only 50 degrees. BC is 65. So 65 is steeper. Okay, think about a ride at Cedar Point or a roller coaster. You know they're building that one. It's got a 90-degree drop. So you go up the roller coaster, and then it looks like this. So this right here is much steeper than any of these because the angle is greater. So the greater the angle, the more steep it is. That make sense? So this right here is 65, so that's a lot steeper. Okay? For me, if I ski or if I snowboard, I like to ski or snowboard down like a 10-degree hill. Like that's my type of hill to snowboard down. Okay? Now, Mr. DeBrano, he snowboards down hills like that. Like 80 degrees. So the bigger the degree, the bigger the steepness. And yes, this side is definitely longer than this side by 3/4 of an inch.
I noticed it because it looks crooked to me, that one side.
It looks crooked?
Well, not, well, I don't know.
I mean, it's because this side is longer than this side. These sides are not equal. It's just like if I were to draw you this. That looks crooked, kind of, right? The reason why it looks crooked is because this side right here is longer than that side. That's why it looks crooked. Okay? You're just so used to seeing this. Oh, it looks perfect. Right? It's like the nose of a pumpkin. Or the nose of a jack-o'-lantern. Well, I think once you carve it, it becomes a jack-o'-lantern, right? Huh? Yeah. Okay. What do we got? How much time do we got left? 6 minutes?
Yeah.
Okay. Let's do this. Remember, we're still constructing triangles. I know. So now we are going to construct a triangle with one angle measure of 50 degrees and one 3 centimeter side. Where do we always start? The base. So let's think about this now. How long am I going to make my base? Hannah. 3 centimeters. So we're going to come down here. 3 centimeters. Bam. Just so I don't forget, I'm going to put 3 centimeters. Oh, wait, 3 centimeters. That was 3 inches. My bad. 3 centimeters. Teeny tiny. Sorry about that, guys. That's 3 centimeters. And how many degrees does one of the angles have to be, Kate? All right, so we're going to put our whole, let's just use letter A because it comes first. You can use B. And where's 30 degrees? Right here. So I put the hole on letter A. I marked 30 degrees. And guess what I'm going to do from here? Connect the dots. Boom. And boom. Now, you do not have to draw this. I just want you to pay attention. Okay? Yes? I did? Take your pen, cross the 50 off, and put a 3. I don't know where I got... I got 30 from my notes, my paper. Real quick, let me show you this. You do not have to copy this down. I'm going to draw another 3 centimeters. I'm going to mark it with letter A and B, and mark 3 centimeters. Now watch what I do this time. Watch this. Now, why am I showing you this? Because either answer is correct. Is this angle right here 30 degrees? Is this side 3 centimeters? Is this angle right here 30 degrees? Is this side 3 centimeters? Did I construct what the question wanted me to?
Yes.
And you're right. Stephanie constructed an acute triangle, and Jack constructed an obtuse triangle. They're both correct. They both have a 30-degree measurement, and they both have a 3 centimeter side. Tomorrow we're going to do in-class work on this. If you could turn your protractors in, that would be great.